Hi guys, welcome and thanks for joining this webinar today, How to Choose the Right Object Storage. I am Mary Poncel, co-founder and VP of Marketing at OpenIO. Few points before starting, this webinar is recorded. The video will be sent and published a few days after this presentation. We want to make this session as interactive as possible, so if you have any question or feedback, feel free to ask them at any time in the GoToWebinar app. We'll tackle them at the end of the session. I'm now happy to introduce our speaker, Enrico Signoretti, Head of Product Strategy at OpenIO. Hi, Enrico.
Hi, good morning, everyone.
Today, the agenda is divided in 4 parts. First, Enrico will briefly talk about OpenIO. Then he will mention some consideration about object storage. We'll then see how to choose the right object storage solution. And we'll finally have the Q&A session. Before starting, I would like to submit a very quick poll. So is object storage part of your IT infrastructure strategy? It's already a part of it. We are looking into it. We won't need it anytime soon, or we don't know yet. I'll let you a few seconds to answer. Okay. Okay, thank you very much. I will share the result at the end of the presentation. I'm now letting Enrico starting the presentation.
Okay, thank you very much, Marie, and thank you again, everybody, for joining us this morning or this evening, depending on wherever you are. And let me give you a very quick update on OpenIO for the ones that do not know us yet. So the company has a very interesting story because the company itself started in 2015, so it's a very young company. But it's interesting because even if we launched the product 1 year ago, the technology has a very long story. So it started in 2006, and the first implementation of our storage platform was in 2009. We proved on the field that we are able to scale from the first installation that was 1 petabyte to 15 petabytes over the years. In the meantime, the original project was open sourced, and this is also why we are an open source company. Last year in October, we announced our first funding round, led by Partech, Elia Partners, and others. Of course, these are very, very important venture capitalists because they are very keen in disruptive technology. So we are very fond of this funding round. Very quickly, a few numbers. So we have 35 employees now. We are growing very quickly. Operation in 3 continents already. Our offices are in Lille. We have an office in Tokyo. We are starting operation in the US too. And it's quite interesting that as a French company, as a European company, we are gaining some traction all around the world already after just a couple of years of having the company out of stealth mode. And we have more than 20 customers. They are growing pretty quickly. Actually, this is not the last number, but I will update next time so you can come back for another webinar. So we have installation ranging from 3 nodes, very, very small, up to 60 petabytes and billion of objects. So it's an incredible platform. And we have now 2 solutions. We started with object storage many years ago. We integrated a serverless computing framework on top of it. The 2 products can work separately, but actually they give their best when they work together. So we do 2 things, in fact. One is SDS, our object store, and it's meant to build cost-effective storage infrastructure that are sustainable at any scale. And the other is great for apps. It hides the complexity of the infrastructure and brings data closer to the application and make them more scalable. Okay. Next generation and serverless computing then. Next generation object storage and serverless computing means two things for us. One, this we build better dollar per gigabyte through the next generation object storage, and at the same time, we create more value from data with the serverless computing framework. If we look at the use cases, our object store is good for many things. Okay, first of all, emails. Emails is not usually associated with object storage because it's an active workload, because the files are very small. But actually, we can manage very small file and billions of them. At the same time, we can manage on the same system big data workloads like large files or archiving or backup. So again, files that are not accessed that often. At the same time, because our integrated data processing capabilities, we can address new use cases. Okay, not just on the archiving as many other objects do, but actually we can do with the integrated data processing, we can address industrial, IoT, machine learning, and other similar use cases where data and application need to coexist to bring the best of the results. So let me do a couple of considerations about object storage before going into the details of this presentation. First of all, okay, object storage is not a short-term project. Okay, so the first example is our first project. Okay, started in 2006, 2007, and it's still in production. Okay, meaning that it's more than 10 years that these guys are implementing our platform, adding nodes, changing node, decommissioning old nodes, and so on. This means that the storage infrastructure that you are building today for today's needs must be ready for tomorrow's challenges. It's not like for other storage systems. Okay, most of the storage systems have a very short lifespan compared to object storage. And you buy the box and you can swap the box with a new box in a few years. But if you build a large infrastructure with the data gravity that you have by adding petabytes and petabytes of data, it's very difficult to move data around, to do migration. So you want to find the right solution. The other thing is object storage is the backend for many solutions. Okay, it's not just one. I use this slide very often just to tell people, look, you can start with a single use case. Okay, maybe you need a sync and share. Maybe you have a web application, or you have to do some archiving. But once you have the object store on your premises, when you have installed it, then you can start using it for many other applications. Okay, it's just you can add more capacity to the cluster, more CPU power or whatever, and it's ready. Okay, the object store is multi-tenant by definition. So let's start with the rest of the presentation with a couple of messages. Okay, so you want to listen to me talking about features, okay, that are available on any object store, because all object stores are identical. They do erasure coding, they do replication. Yes, it's a very standard thing. Okay, but we are different, and there are some differentiator in our technology that makes our object store a different kind of product, a different kind of platform. In fact, we think about ourselves as next generation object storage. This is why we always use this next generation object storage payoff. So how to choose? First of all, look at scalability. Okay, scalability doesn't mean that you can't build large installations. Again, everybody in this domain can do scale out clusters. Okay, so you take a standard server full of disk, you put many of them in the same system and in the same infrastructure, they are connected together, and you obtain a pool of storage which can be as large as you want. Okay, what's the problem then? The problem is that you want to scale when and how you need it, okay, without constraints and limitations. This is the difference. And how it works. So a traditional object storage is based usually is presented, its layout is presented as a ring, okay, where you have this distributed hash table. Each the key space is divided by all the nodes, so each node has a part of the key space. Usually they are distributed evenly in the cluster, okay, and also this goes also for the data. This distributed hash table is very efficient from the point of view of scalability. So it can be very large, okay, but it's not really granular. In most of the implementation in the market do not allow to separate data from metadata, for example, or to have nodes of different sizes, okay, in the same cluster. And also they are based on an algorithm called chord. And this is a problem because there is no performance consistency. So the way this peer-to-peer kind of protocol means that it's not so the number of hops that you need to find your data in the cluster could vary depending on the size of the cluster itself. And the last thing is that every modification you do on the cluster creates a data and a key space rebalancing that could take hours, days, sometimes in very large cluster it could take weeks. So we use a different mechanism here at OpenIO. So we use a distributed directory, okay. It gives us a lot of advantages. So the same level of scalability, because it's a form of distributed hashing, but it's much more granular than the traditional approach, okay. It gives us, in fact, the ability to distribute data in the cluster and the key space in different nodes in different ways. Also, we can have nodes that are just for metadata, for example, and nodes that can do a little bit of everything, and nodes that just manage data. And also another important factor is performance consistency, meaning we always need 3 hops to reach the data, no matter the size of the cluster. So if you have 3 nodes, it's 3 hops maximum. If it's 300 nodes, it's 3 hops, meaning that you reach data always with the same latency. And we don't need rebalancing. For the same cluster, for the same mechanism that is implemented here, we just add more nodes to the cluster. I just want to give you a couple of examples here, because we did a POC for now a customer, and so they tested several different technology. Okay, the closest competitor, and I'm taking the closest because there were other competitors. So this customer tried the S3 protocol, erasure coding, 1 petabyte just for doing the test, 20 nodes cluster, so small nodes, and 40 injector to push data, different workloads, different kind of files, and so on. Okay, what happened? Look, I just give you another information. So this closest competitor took 2 weeks to tune the system. We just went to the customer and did the same work in 2 days. And this is another factor of that you could consider when you start evaluating an object store. So what happened during this benchmark? Easy. Okay, We were faster. Yes, in fact, we did. We won the customer, okay? But not just faster. We were consistent. If you look at the graph here, you will see that our competitors has very scattered performance. So they are not consistent, limiting the number of use cases they can address. Okay. On our case, our line is flat, totally flat. We reach the limit of the hardware, and then when the system at this point there was a failure in the network, we managed also the failure of the network. So we didn't have a crash, or we didn't have a peak in performance, in latency, or whatever. Just we managed it smoothly. Okay, and this is why we won, of course. So look at this example, for example. Sorry, look at this example. This customer, okay, we usually say, okay, they have 60 petabytes. In fact, they bought 60 petabytes from us, but actually they are implementing the clusters over time. So they started with 15 petabytes, and they keep adding nodes. They are not buying like 20 nodes every time, also because they are pretty huge, but they are buying one node at a time. So they have a contract for which they receive a new node every few weeks, every month, and they just add the node, and they plug all the cables, they turn it on, they configure the node, and the node start working and does its job. Okay, no rebalances, no everything, easy. So there is another thing, because as you probably already know, we are a software company, and OpenIO, SDS, and Grid for Apps are two software solutions. Okay, and we always talk about software defined, meaning that you know, most of the people think about software defined as a software that you install on the hardware. Actually, it's not true. Okay, it's a totally separation between the control plane and the data plane. Okay, we think we are really software defined because we take advantage of any hardware you put in a cluster. I just want to make a very small example here. In our lab, we have clusters made of x86 RAM and one MIPS machine. Not in production, the MIPS machine, but actually there are three different architectures in the same system, just to prove the flexibility and the fact that we can do it. Okay, so the ability to take advantage of any sort of hardware that you need efficiently. Why? It's simple, because things change over time. Okay, so in a traditional system, you have a static load balancing mechanism. Usually data are distributed evenly in the cluster, so accesses and reads and writes are distributed the same way. Okay, all nodes should be similar. Just when you start implementing the system, you choose a node, and you want that that node to be replicated all the time. If you over time start to buy larger nodes, you have to implement, in some cases they call them virtual nodes, so some virtual nodes instead of the physical node to emulate the size of the original node. Okay, it adds a little bit of complexity. It's also difficult to explain, so I think that just the fact that it's difficult to explain means complexity. Okay, and again, you have lack of granularity, because you have to think everything in multiplies of the original cluster, of the original configuration. It makes me crazy just to think about this. Okay, and I think you too. So what do we do to solve this problem? We don't do it. So I told you we can just add nodes and make the best out of them. In fact, we have a mechanism called conscious technology, which is a very simple mechanism. Every single node in the cluster computes a quality score. The quality score is calculated with a formula that includes RAM, CPU, network, capacity of the disk, throughput of the disks, and so on. Okay, so you have this score that ranges from 0 to 100. 100 is the best, and we do this score computer thing in real time, and all the scores are collected. For every single operation that happens in the cluster, we just query the conscious technology, and we get the best nodes, and we write always data on the best nodes. So this is a dynamic real-time load balancing, and of course, it if I put in the cluster a new server, and this server is better than the old one, the older ones, also because it's empty. I have a new CPU, I have better disks, probably larger disks, so the score is just better. It will be hit the most at the beginning, but then over time, because there are so many hits on the node, its quality score will go down. And so the system is always optimized, and we support heterogeneous hardware in the same cluster, meaning that you don't care what we will be available in 6 months from now, 2 years from now, 3 years from now. You will be able to buy the hardware that you need and use it 100%. So look at this is the same use case that I showed you at the beginning. So we started with this. Okay, so these guys started in production. It was 2009, right? So, and before that there was a period on testing and so on. Let's say 2009. We are in 2018. It's 9 years, right? And in 9 years, think about how many hard disk sizes changed. Think about CPUs. Think about the disk. Think about the network. Okay, they have the cluster running with old nodes and new nodes. Actually, they have 600 nodes. Okay, and many of them are different from the original ones. And you know what? This is nothing, but this is a large installation. They let nodes die. They don't do maintenance on the older nodes. When the node die, they have new nodes coming in. Okay, because it's easy. It's easier and less expensive than doing maintenance. Okay, it's usually in the large scale providers anyway. So let's talk about another topic: dollar per gigabyte. I want to be honest. Okay, the first thing everybody looks when we start talking about object storage is money. Okay, because they want to spend less because they are spending a lot of money with traditional storage. Okay, and they want to spend less in managing the infrastructure, the storage infrastructure. But I can tell you, okay, that there is much more than TCA and TCO. Okay, over time we can prove that we have a very good TCO because the other characteristics are here, but do you want more now? Okay, it's not just the fact that you can save money by saving data in our system. It's just we can create value from the data stored in the system. Okay, and in a traditional object store, many object stores in the market, not all of them actually, but many are working on indexing and searching capabilities. Okay, it's a nice thing. Okay, I'm not telling this is nice. We can do that also, but it's nothing special. Okay, they do have basic application integration, and yes, most of them are just data stores. Even when they talk about IoT or they talk about big data, it's very cool, but actually they are object stores for big data and they are object stores for IoT. Nothing really special. Okay, we We started working on a serverless computing environment many years ago, without at that time knowing that it was serverless computing. Okay, serverless is a buzzword that came up not a long time ago. Okay, we did it because when we started working on the system, our developing team did a very good job. I shouldn't say that, but you know, we are selling our product here, so yes, maybe I should. So the idea is the product is very lightweight. Consider that we can run on a Raspberry Pi. The full stack of our product can run on a device as small as a Raspberry, meaning one ARM core and 500 megabytes of RAM. Okay, and the rest of the system, we use most of it, okay, for caching or you know, erasure coding, yes, but you know, most of it is idle. Okay, so we started thinking about doing more and more with this CPU power that we have, and we started doing the serverless computing. Serverless computing is a very nice thing because you write a piece of code, a very small piece of code, okay, and everything in the system can be intercepted. So each single event, like write, read, an update on a file, whatever, okay, it's intercepted, and we can trigger a function. This function, the code, the piece of code that you've wrote before, okay, does little operations, okay. So it's not SAP running on the object store, but think about metadata enrichment. Okay, we can scan the content of the file that you are saving in our system and tell you informations and build metadata on top of it. We can scan for viruses and put the object in a quarantine space. We can do almost everything, okay, on data, and also interact with external systems. For example, it's quite nice this use case where you put an image in our system. Okay, we intercept the event, and it's queued in our queue manager. Then it is pushed to a small function that uses TensorFlow. TensorFlow is a library from Google. It's a public domain library, so you can find it and download it and use it. Okay, nothing special here. This library, we use it to do image recognition. So we recognize that the picture has a volcano in it. Good. What do we do? Yes, we do the indexing and for searching later time. Nice. But we also create a metadata category volcano. Okay, and we put this in the volcano. You know, all the services like iCloud Photo or Google Photo or whatever photo that you're using from your phone that recognize your face and the face of your kids. This is the same identical thing. Okay, but you can build it with 20 lines of code, okay, on top of your storage system. I think it's amazing. So I'm just giving you another example here. Okay, so we built this POC for a media entertainment guy, and he wanted to do some workflow automation, okay, and video enhancement. So what do? So they have this camera. They have to put the videos at standard 1080p resolution, and they want to put a watermark on each single video. Okay, so usually what do? So you save the video, you upload, you read the video from a workstation, you do this work, and then you save the video back again. Nice. It takes time. Maybe it could be automated, but you have a separate compute cluster that has to do it, and so on. What do? The customer just saves via NFS the video in the system, and the video automatically do the transcoding. So the object store does the transcoding and adds the watermark. of course, using another software that you can find in the public domain, FFmpeg, is very standard. Okay, then the video is ready on in one of our containers, and it can be accessed via HTTP for streaming. So actually, at the end of the day, we are moving from a complex workflow to saving a file in an object store. Okay, it saves you time, it saves you money, and easy and without any human intervention. So once more about the costs, but it's in a different way this time. Okay, it's about licensing. Okay, we are an open source company, and but the way we think about our infrastructure, the way we think about charging the software is a little bit. We think it's a very, very cost effective, but also convenient from the business model point of view. Okay, we are able to build on-premises infrastructure that are as flexible as cloud, but cheaper. You could not believe this, but it's quite interesting to note that we are implementing the same business model of the cloud. So you pay only for what you are actually using. Traditional object store, proprietary software at least, okay, it's a form of lock-in, okay, and mostly capex. So you buy the license and you add a support contract on top of it. Okay, it's nice. It's very, very, pre-cloud era, in the sense that we are moving to an OpEx world. So thinking about CapEx is also a problem. Same thing about the fund that you are buying proprietary software. This is a conversation that happens every day to us. Okay, but you are a startup. Yes, but you have an open source software. So actually you have the control of the code. Okay, there are contributors, and so your infrastructure can survive for many years. Okay, so no lock-in, and you are not forced to work with us for forever. Okay, so we are an open source software. We have a free software. You can download it from the internet. In fact, we have a community plan that is available where you can get support from our Slack community. Okay, doesn't mean that you don't need a paid plan, because there are some features that we support only on paid plans, especially if they are mission critical features and you want real-time support and you want bug fixing quickly 24/7 and so on. Okay, but there is no lock-in. Okay, this is very important, and everybody at the CIO level, CTO level, whatever, they are looking for no lock-ins. And also it's OpEx friendly, so it's a subscription. So you pay for what you are actually using at that moment. Okay, so it's a very pay-as-you-go. Let me give you another example. Okay, these guys, so they started with Amazon because it's cool, because you are a startup, you want to start with Amazon because it's easy. Okay, but after a while, they discovered that we are spending a huge amount of money, not because Amazon is not good or whatever, just because you pay everything. So you don't pay only to store data on Amazon or any other cloud. I'm just making an example here, but you pay for retrieving your data. You pay to move data around. You pay for everything. Okay, everything that moves, you pay. So these guys, what did they do? So they just went to a bare metal cloud provider. So they rented servers, physical servers. Each server comes with features included, so including network bandwidth and so on. And they just installed our software. So they built 35 nodes cluster just for 350 terabyte, and I can assure you that it takes 10 minutes to install a 35 node cluster. We have an example on our resource library where we install 48 nodes in minutes. And so these guys have 10 billion objects. they do, you know, every time you access their web page, they do they download on your browser all these objects. Okay, so there are a lot of back and forth between your web browser and our object store now. And in the just in the first year, they saved 400,000 euro. Well, this number per se doesn't mean anything. Okay, it's a lot of money, but no, it doesn't mean anything. They were spending 500,000 with Amazon, meaning that now they are spending just 20% of that money. Okay, that's the number. So they saved 80% of the Amazon costs. Okay, and for some operation, just because they can fine-tuning the application now and they can fine-tuning the infrastructure, they reach 10 times better performance. I think this is a nice use case. In fact, I mention it all the time. And last but not least, there is the ecosystem. Okay, so I told you at the beginning, the object store is the backend. Yes, it can be accessible via S3, which is nice. So potentially any sort of gateway, any sort of solution is compatible. We have a nice Docker container, for example, that you can install on a PC, and if you have and if you are a developer, you can test your application against our S3 implementation. So it's easy. Theoretically, you can do that, but it's even easier, especially in the enterprise, having end-to-end certified solution. So you don't have to think about it. It's just a turnkey solution. We have a couple of solutions already in place. One is OYOFS, which is a file system interface, gives you the ability to mount the object store as a file system. So easy to access, for example, for legacy applications, backup and archiving when your old application or your backup server needs a file interface. Good. And then we have Grid for apps for the serverless part. Okay, so you can build your code and do any sort of integration with other system in your infrastructure. But we are building an ecosystem also of third-party solutions. So with hardware vendors, with email integrations, with sync and share, with cloud providers, and so on. And also we have we are growing a partner ecosystem in terms of resellers and system integrator to make this even easier for the end user. Here an example which is quite nice from my point of view. So these guys started with us. Again, I like to show large multi-petabyte installation, but you know, you can start very small with our object store. So in this case, it's 80 terabyte. Okay, it's not huge. It's interesting because they are serving through one of our partners, SME, Storage Made Easy, sync and share 2,000 of mobile and desktop clients. It's enterprise sync and share at the end. Okay, they have 2 sites, disaster recovery and everything. This is certified end-to-end and installed by our system engineer, and it's a cross-reference between SME and us. So it's a quite nice, I think, kind of end-to-end solution. We are working to build more and more on them. You will see in the next 6 months other similar solution coming out. And this is something that I really love because the world is changing so quickly, and you have to be ready. When I told at the beginning that you are starting thinking about your system now, but object storage is something that will last probably forever, I hope so. Now we are moving from the hard disk world to the flash world. Okay, in the picture here you see a flash drive. It's 30 terabyte in 2.5 inches. Okay, yes, it's still expensive. Okay, I do not have the price. I can guess it, but you know, it's very expensive. But what I want to point out is that you you want to work with any media. You don't really care. Okay, today you need hard disk. I'm okay with it. Tomorrow you need flash. I am okay also. And look at the number anyway, because yes, today the hard drive costs less. So the dollar per gigabyte, the raw dollar per gigabyte, is very, very low for the hard drive. Okay, but everything else is not on the hard drive side. So the largest drive available today is 12 terabytes in a form factor which is 3.5 inches. Okay, you can have 12 of them in 2 rack units. This is very slow. The number of IOPS is ridiculous, and it has a high power consumption and also an high failure rate. Okay, even if it's not that high, is higher than the flash. Okay, look at the flash memory. Yes, the cost of the single drive is probably 10 times, probably more than that. Okay, but you have 30 terabyte in 2.5 inches, meaning that it's 5 times denser. Okay, 5 times. So in a 2 rack unit server, you can have something like 720 terabyte today, and probably more in the near future. Okay, it's incredibly fast. So you can do applications that are not possible with disks today. It has a power consumption that is 5 times better, 5 times. Okay, if you are concerned about power consumption, maybe at the end of the day, in a large infrastructure, this number makes a difference, and it's much more predictable regarding the failures, and overall, the efficiency of the whole system is better. So yes, and the most important point that we are flash optimized. I just give you this example. This is an internet service provider in Japan, so on the other side of the world, and they do 6,000. They save on our system 6,000 emails per second, and they don't just save the emails. They also do the indexing, okay, for anti-phishing, anti-spamming, anti-scamming, anti-everything. I don't know, and they have these 2 sites, and the RPO and RTO is 5 minutes. Okay, and all of this is possible with 10 plus 10 nodes of all flash. Okay, so we can. I think it's amazing. Okay, because you are just raising the bar of what is possible with object storage, and you know, today is for corner cases. Yes, tomorrow it will be for everyone. I think this is, yes, this was my last slide.
Great, very interesting. Thanks a lot, Enrico. I can share the result of the poll before the Q&A session. So the question was, is object storage part of your IT infrastructure strategy? And your answer at 64% that you were looking into it, 18% that it was actually a part of it, and 9% each for the last 2 answers. Okay. So I'm now going to take the first question. So Enrico, no rebalancing sounds interesting, but can I rebalance data if I want it to be evenly accessed across the cluster?
Oh yes, it is possible. It's not that everybody uses it in our installations, but there is a function you can manually rebalance the data. Actually, you can also put some rules, and because we can organize data in storage pools, so it's quite sophisticated, and there are many options to do that.
Okay, great. The second question, I'm already working with object storage. What happens in case of a failure? This is the worst nightmare for me at the moment.
Ha! I knew that. No, I'm telling this because this is something that happens very often to me. So yeah, rebalancing is a pain in the neck for many of traditional object stores. Okay, it's quite we choose a different approach. Okay, if a failure happen, we don't do anything. We wait. Okay, also because we implemented a lot of mechanisms for which we can take off a node even for weeks, and when the node comes back, it's just resync the modified data. Okay, there are mechanisms that we implemented, if we have enough resources, of course, in the cluster, where you can continue to write to other nodes, okay, and access data to other nodes without rebalancing, because you know that maybe tomorrow you will have the node back. Okay, and we have customers using this kind of feature in production, so you can do the rebalancing. But again, is it necessary? Because if you have an x86 server with 90 disks in it, and each disk is 12 terabytes, we are talking about more than 1 petabyte. Are you sure if that server fails, you want it to be rebalanced, or do you want to wait a few hours that the technicians comes in, does it work, brings the node back, and you just resync a few terabyte or even hundreds of terabyte instead of several petabytes? I don't know. It's you can choose. So freedom of choice.
I have a last one. You didn't mention data protection at all. What is your recommendation?
No, actually, we support several types of data protection, in the sense that we do the multiple replicas like many other object stores. Erasure coding, it's another option. Actually, we have a functionality that automatically selects the best data protection mechanism depending on the size of the data that you are storing. So what happens? Erasure coding is fantastic. Okay, it has only a small problem, that if the data is very small, the size of the final, the sum of all the segments will be several times the size of the original data. Okay, because to calculate the erasure coding part, you need some information, and it could be that if you are storing a mix of small files and large files, the small files can be very, very large at the end. So when you save the data, we just you put a policy on the container, which is our bucket, and you say, okay, for this bucket, I want that files smaller than that size, this size will be replicated 3 times, and file, I don't know, larger than this size will be erasure coded 9 plus 3, 14 plus 4, or whatever you choose. And this saves a lot of IOPS as well as a lot of capacity at the end, so it's very efficient. And if you have a multiple data center, you can do distributed erasure coding, or you can have synchronous or asynchronous replicas depending on the bandwidth and other factors. So it's the layout of the cluster is very flexible, as well as the data protection mechanism that you can apply.
Okay, thanks, Enrico. It was the last question, so thanks everyone for your time. If you want to continue the discussion, you can find a lot of the information on our website, openio.io, and on docs.openio.io. If anybody has additional question or even feedback, please reach out. We'll be very happy to answer. You will receive the recording of the webinar in the next few days. Have a nice day, everyone, and I hope to see you next time.
Thank you very much from me too. And if you want to continue the conversation also on Twitter, you can find me at esignoretti, which is my last name plus E in the front. And that's all. Thank you very much again. Bye-bye.
Thank you. Bye-bye.